Hey everyone, Ivan here. Before we dive in today's fascinating topic about how your brain changes after age 25, make sure to hit that like button and subscribe to the channel for more insights on brain science and personal development. If you ever felt frustrated when learning something new, whether it's playing an instrument, coding, or mastering a sport, today's video could completely transform how you approach learning. What if I'll tell you that the frustration you feel when making mistakes is actually your brain's superpower, not a sign of failure? And what if understanding this could help you learn faster and more effectively, especially if you're over 25? Stay tuned because I'm about to share some game-changing insights that could revolutionize how you approach any new skill. Well, as Dr. Andrew Huberman explains, that around age 25, something significant happens in our brains. While the brain remains capable of change throughout life, there's a distinct shift in how this plasticity works. And as according to this research from the National Library of Medicine that we have here, contrary to all belief that the adult brain is fixed, science now confirms that the mature brain remains highly adaptable. However, the mechanisms change as we age. While a young brain under 25 can make large dramatic changes easily, the adult brain requires different triggers to achieve similar results. This difference explains why children seem to effortlessly pick up new languages or skills, while adults often need more structured, deliberate practice. The key insight here is that adult brain don't lose the ability to learn. Just need different conditions to activate plasticity. And surprisingly, making errors is central to creating those conditions. We're going to see here that what is actual neuroplasticity means. The term it was by the father of neuroscience, Santiago Ramon and Cajal, from 1852 to 1934, who described non-pathological changes in the structure of adult brains. The term stimulated a controversial discussion as some neuropathologists favored the old dogma that there is a fixed number of neurons in the adult brain that cannot be replaced when the cells die. In a wider sense, plasticity of the brain can be regarded as the ability to make adaptive changes related to the structure and function of the nervous system. Accordingly, neuroplasticity can stand not only for morphological changes in brain areas, for alteration in neuronal networks, including changes in neuronal connectivity, as well as the generation of new neurons, neurogenesis, but also for neurobiochemical changes. You can see here some really cool insights about the neuroplasticity in this cool article. There's a lot of here more details in depth if you wanna see it, but it's, I don't know. This is for more for a. It's understandable, but it's for more doctor terms, medical terms. So I'm not a doctor. That's why I'm not trying to just be like a doctor. Just try to find to show you the most valuable information. Here in the neurogenesis in adult vertebrates, as you can see, the most appealing phenomenon of neuroplasticity appears to be adult neurogenesis, that is, the generation of new neurons in adult brains. Neurogenesis takes, of course, place in the developing central nervous system, but in view of the fact that certain illnesses such as Parkinson's disease and multiple sclerosis occur in adulthood, the interesting question is whether also adult brains are able to replace lost neurons. Now, from another, this is an MD doctor. It's a doctor in medicine. It is Dr. Norman Deutsch, that he wrote a really nice, great book that is The Brain That Changes Itself. It's one of the best books to try to. As you read this kind of books, you will learn more about this insight about how the brain neuroplasticity works. It's a really nice, great book. The Dr. Deutsch is a psychiatrist and author of this great book that has extensively documented how neuroplasticity works through remarkable case studies. That's this book all about, just case studies, but we learn as we read it. It's really nice, beautiful book. The Dr. Doge has revolutionized our understanding of the brain by showing how it can rewire itself throughout life. In his work, he demonstrated that even people with significant brain injuries or lifelong conditions can experience remarkable improvement through targeted neuroplastic interventions. One of the most important aspects of the Doge work is the idea that mental practice and focused attention can create physical changes in the brain. When we struggle with a new skill, we're not just learning movements or memorizing facts. We're actually rewiring neural pathways. According to Doge research, neuroplasticity is activated most effectively when we're engaged in novel, challenging activities that require our complete focus and attention. This aligns perfectly with Huberman's discussion of the error-driven learning process. The most powerful neuroplastic changes occur when we're actively engaged in learning something new, not when we're simply repeating a skill we've already mastered. This means seeking out the zone of difficulty where you're making errors, but still motivated to improve is precisely what leads to the most profound brain changes. Well, combining insights from both Huberman and Deutsch, we can identify specific strategies to maximize learning as an adult. As what they said, it's not my advice, it's just from the doctors. Since adult brains don't make massive shifts as easily as younger brains, breaking learning into smaller pieces leads to more effective progress. Another is when practicing, deliberately push yourself to the point of making errors. Continue practicing through that frustration for about 7 to 30 minutes. This specific time frame allows the neurochemical cocktail of epinephrine, acetylcholine, as Huberman said, and eventually dopamine to properly signal your brain that change is needed. And this is fascinating. Train yourself to attach positive emotion to the feeling of making errors by consciously telling yourself that errors are valuable signals for learning. You can enhance dopamine release, which accelerates the plasticity process. And to realize that the actual rewiring happens not during practice but afterward, during sleep and rest. This means that short focus, error-filled practice sessions followed by adequate rest are more effective than marathon sessions without breaks. And finally, identify your peak mental alertness times during the day. Schedule your most challenging learning sessions during these periods when your brain is naturally more receptive to change. As I'll tell you, I'm not a doctor, so just based on from books, articles, study cases, and that's the information that I give you. That is really valuable information. So I'm gonna give you some reference in the description of the video. Well, and if you find this insight valuable, please hit that like button and subscribe for more content on optimizing your brain's performance. Also, drop a comment sharing your experiences with learning new skills as an adult. This is Ivan helping you understand the science of learning and brain performance. Thanks for watching, and I'll see you in the next one.